Chapter 14, Gases, Part 6, Bernoulli Principle. Bernoulli's principle, in its simplest form, states that when the speed of a fluid increases, pressure in the fluid decreases. The discussion of fluid pressure thus far has been confined to stationary fluids. Motion produces an additional influence. So the relationship between fluid pressure and speed could be explained as follows. Most people think that atmospheric pressure increases in a wind stream, tornado, or hurricane. Actually, the opposite is true. The pressure within air that gains speed is actually less than for still air of the same density. When the speed of fluid increases, its pressure decreases. Now, if we consider a continuous flow of water through a pipe, the amount of water that flows past any given section of the pipe is the same as the amount that flows past any other section of the same pipe. This is true whether the pipe widens or narrows. The water in the wide part obviously will slow down, and in the narrow part it will speed up. Because the flow is continuous, water speeds up when it flows through a narrow or shallow part of the brook. So Daniel Bernoulli, a Swiss scientist of the 18th century, advanced the theory of water flowing through pipes. So Bernoulli's principle describes the relationship between the speed of a fluid and the pressure in the fluid. The greater the speed of flow, the less is the force of water at right angle sideways to the direction of flow. So the pressure at the wall of the pipe decreases when the speed of the water increases. Bernoulli found this to be principle of both liquid and gases, means it applied for fluid. Bernoulli principle is a consequence of the conservation of energy. Simply, he stated that higher speed means lower pressure, and lower speed means higher pressure. In this case, we must distinguish between the pressure within the fluid and the pressure exerted by the fluid on something else that interferes with its flow. The pressure within the fast-moving water in a fire hose is relatively low, but the pressure that the water can exert on anything in its path to slow it down may be huge. Streamlines. In a steady flow, one small bit of fluid flows along the same path as a bit of fluid in front of it. The motion of fluid in a steady flow follows what we call streamlines. Streamlines are the smooth passes of the bits of fluid. The lines are closer together in a narrower region where the flow is faster and pressure obviously is less. Pressure differences are evident when liquid contain air bubbles. The volume of an air bubble will depend on the pressure of the surrounding liquid. So where the liquid gains speed, pressure will be lowered and bubbles are getting bigger. Bubbles are squeezed smaller in the slower higher pressure liquid. So water speed up when it flows into a narrow pipe. The close together streamlines indicate increased speed and decreased internal, as shown in figure A. In figure B, the bubbles are bigger in the narrow part because the internal pressure there is less. Bernoulli principle holds only for steady flow. So if the flow speed is too great, the flow may become turbulent and follow a changing, curling path known as an eddy. In that case, Bernoulli principle does not hold, so is only applicable for a steady flow. Conceptual question: what does Bernoulli principle state? Let us now talk about some application of Bernoulli principle. Wind blowing across a big roof can lift the roof off of the house. Why that? This is because the pressure is reduced as wind gains speed as it flows over the roof. The greater pressure inside the house will lift the roof up. Another application: perfume atomizers, as in shown figure. Air rushes across the open end of the tube when you squeeze the bubble, reducing pressure in the tube. So atmospheric pressure on the liquid below will push it up into the tube, and with the air it will be atomized, as shown in the figure. More application: trucks passing closely on a highway are drawing to each other. Reason: air pressure between the truck is less than pressure on their outer side pushing inward. Again, risk of passing ships colliding sideways. Reason: water pressure between the ships is less than pressure on their outer sides. This will let them pushing inward. Question: on a windy day, waves in a lake or the ocean are higher than their average height. What factor in Bernoulli principle contribute to the increased height? You have option. The factor is reduced pressure will pull the water upward, or pressure build up over the crest, or air travels faster over the crest than the trough, or none of the above. The proper answer is air travel faster over the crest than the trough. If the trough of the waves are partially shielded from the wind, so air travel faster over the crest, pressure there is thus lower than the down below in the trough. The greater pressure in the trough push water into the even higher crest.